Okay, so this lesson is on polygons. So a polygon is a straight-sided shape. So what we mean by that, it could be, you know, as long as they're all, it can have like that, as long as they're straight, yeah? Straight-sided shape. So if you have a regular polygon, it means all its sides are equal length. So an example of a regular polygon is a square, yeah? Because all sides are equal. Another example of a regular polygon is an equilateral triangle, yeah? Because all of its sides are the same. And other ones you're going to see is like, you know, if we had a hexagon, you know, exactly like that, that is also a regular polygon. So they're going to say this hexagon is the regular polygon, so that means you know the sides are all the same length, okay? Now, what it's saying here, sorry, I'm just going to change the colour. Here it says the polygon with n sides can be divided up into n triangles. So let's have a look at the ones I just drew. If you think, how many sides does this square have? It has 4. So can you see, I can divide that up into, can you see the 4 equal triangles? They're all exactly, they'd be the same sort of size, yeah? Now also I could divide this triangle up as well, yeah? So if you look like that, yes? So it has 3 sides. Can you see how I've made 3 inner triangles in there? Can you not see that one? I'll do that one again. So see how I'm dividing from the center there? And do I not create 3 triangles all the same? Yes? And the same, how many, if this is a hexagon, 6, I'm going to get 6 triangles. Can you see this? Yeah? Oops, like that. I get 6 equal triangles. So what could you also see about that is, I just want to show you, so maybe if I draw the square one. So you know this is a square and you can divide it into thing. If you know like that's a square, can you see that's a full circle there, isn't it? So that's how much in a full circle is 360. These triangles are all exactly the same. So that means that angle in there would all be exactly the same. So what could you do? You could say 360 divided by 4, which is 90. So you know that that angle is 90. Can you see how you can work that out? Yeah. And so what about up here? You've got a 360 here and you divide it by the 3 triangles. So that top angle up there is 120, yeah? Can you see that? So you might have to look into that. That might be a thing that you use to solve, a problem. Okay, so when they talk about this, the sum of the interior angles. So the sum of the interior angles can be found using this formula. So you've got the sum. If you think so, let's go over here and we'll just think about a square. If you've got a square, aren't they all 90 degrees? Yes? And what would all those, if you summed up or added up all those angles inside, what would it equal? 90, 90, 90, 90. It would equal 360, wouldn't it? Yeah? So we're showing you that this formula, we can use that formula and do that. So if you said, we said the sum equals, now you can just use that 180 times n minus 360. So we would do, if it was a square, you go 180 times 4, because there's 4 sides, minus 360. So that ends up being 720 minus 360, so 360. So can you see how I'm sort of proving that formula for you? But we don't need it for a square because we know that common knowledge. But what about if I had this hexagon up here? Can you remember how much all those angles add up to? Probably not. Or what if I give you a 12-sided regular polygon? So that's where you will use that. Now, if you just want to know, sorry, this was supposed to be a pentagon, I think. If you just want to know the size of one interior angle, so that would be, say, for example, we just want to find that one, we can use this formula. So if I was doing that example over here, I would say, so this is, we're calling that x. So it'd be 180 times 4, because a square has 4 sides, minus 360 divided by 4, and you're going to end up with 90, okay? Obviously, easy for a square, we know that common knowledge, but we don't know all the other ones, so we might need to work that out, so you use that. All right, so interior here, yeah? I'll cut it for you. There you go. Let's go on to an example. They've said that find the sum of the interior angles of an 8-sided convex polygon or an octagon. So n equals 8. Okay, so you can see I've written out the formula and then I've substituted that in. So the sum of the interior angles of an 8-sided thing is 1080. So that's a simple. They might use, see how they use the word octagon? But they are going to be very clear and tell you how many sides they are, because English might not be the first language of all people doing this maths test or exams. So they don't use the, like, you know, what's like a decagon and all that. They will tell you how many sides it is. So you don't need to stress too much. They might use the word in there, but still communicate what that is, because it's an unfair advantage. Interior angle, where was your to others? All right, so exterior angles, so we can say again, they will all add up to 360. We said that before, of a regular polygon. So even here, where we've got the 5-sided shape, we know that those exterior ones are going to add up to 360. So you essentially can work out what that angle is if you needed to. So you can use this, otherwise you can use this formula here, so which could tell you as well. The exterior angle is that. So for regular polygons with n sides, it can be split into triangles with equal numbers of sides. So that's exactly what I just told you anyway before. So say up here, oops. Remember how I told you this one has 5 sides? So I could get 5 triangles out of that. Can you see that? 1, 2, 3, 4, 5. Okay, that's what this little statement was saying. I already explained it earlier. So I'm going to kick back and look at your formula. Where was it? Back. All right, so here's a couple of questions. So calculate the interior and exterior angle of the polygon. So let's look at the interior. Oh, sorry, they've used red. So here's the red. So they wrote the formula, which was here. So, sorry, interior angle, the formula would have been 180 minus 360 divided by n. So we can see that this has 5 sides. Okay, and then they've asked you to get the exterior, exterior angle here. So they've used the exterior angle rule, which we just saw on the other page, was x equals 360 divided by n. So because that's 5, they've used 5 and they've found out. So they know that this is 72 there, and they knew that this one is 108. And it looks like 108, doesn't it? Yeah. That's good ways of checking whether you're right. They're not going to give you unrealistic looking shapes. So before, when I did that, it was pretty bad when I said, oh, call this. I shouldn't have said that. So you can see that does look like 72, doesn't it? It's not quite a right angle. So they're good ways to know you haven't stuffed it up, because you sometimes will make the same mistake. All right, so this is taken from an exam. So it says A, B, C, D, E, F is a regular hexagon. So see how even if I don't know hexagon means 6 sides, you could count them, couldn't you, if you had to? Is that true? Yeah? So what is the size of the obtuse angle FOD? So when you see this FOD, what they actually want is it's the angle in the middle that they want. So you're going like this. You're going FOD. So this bit is the question. Whatever letter's in the middle is the question, all right? Now, remember before I said if you have a regular, which they did tell me, didn't they? They said it's a regular. Remember we said we could break that up into, because it's a 6, I could get 6 equal triangles, couldn't I? And remember I said that this would be 360, wouldn't it? So if I divide 360 by the 6 sides, or 6 triangles, see, 1, 2, yeah? What would that little angle in here make it? It'd be 60. So I'm just going to rub that out. Don't worry, it'll be on the video. So we said we want this, and that's the question. Now, you just told me before, when you broke it up into your, you said that was 60. So I've got 2 of them there, haven't I? In that. So how big is that FOD angle? It is. Was 360 divided by 6? No. Where's the answer there? Oh, no, this is another question. Sorry. Yeah, so you just had to say it is 120. Sorry, that's another multi-choice underneath. I thought this was a multi-choice of this. Sorry. Okay, this is question 2. Another question. So the side, what interior angle of a regular 16-sided polygon is equal to? So you know that n equals 16. You want the interior angle. So we said the formula was 180 times n minus 360 divided by n. So you would do that. So it'd be 180 times 16 minus 360 divided by 16. And what was the answer? Okay, so the answer was that, 157.5. Boys, come on, keep going. The size of an interior angle of a regular polygon is 165.6. What's the value of n? So you know you're looking for the interior angle formula, which we just did before. So it was 180 times n minus 360 divided by n. Now you know what it actually is equal to. So I know 165.6 is equal to 180 n minus 360 divided by n. Can you see I only have n is the only thing I don't know? So you can pop it in solve and do that. Okay, so we got n to equal 25, which was the answer there. All right, this one I know for sure is from an exam because I can tell. So question 1 on the exam, so this one should be an easy one because it's the first one of the trig. So the wheels of 5 spokes are equally spaced around a central hub as in the diagram shown below. What is the angle between the 2 spokes is labelled on the diagram. So this is pretty easy, isn't it? We know that that is 360 and we've got 1, 2, 3, 4, 5. So you're just going to go 360 divided by 5, which is 72. Yeah? So D. All right.